curve with equation y is equals to 2x minus 8x to the power 1 over 2 has a minimum point at A, okay, and intersects the positive x-axis at B. Find the coordinates of A and B. Okay, actually we don't need to draw this, not necessary for us, but still it will help us out. So they say there is a curve, okay, that has a minimum point at A, okay. It must not be like this, it must be maybe like this, okay. So they say that it has a minimum point at A and intersects the positive x-axis at B. So this is your point B, okay. Why I made this quadratic equation? Because it seems not to be a quadratic, but it seems to be a disguised quadratic, because we have, like in a quadratic equation we have x squared plus 2x plus 3, something like that. Here we have x to the power 1 and half of that x to the power this. So this type of equation is called disguised quadratic, where you have double power and then half the power and then constant term, maybe or maybe not. So it will be a quadratic equation like this. Coordinates of A and B. Okay, so whenever we have a minimum point, that means it has a stationary point, and for the stationary point, what do we have? The relation that we have is that for the stationary point or turning point, whatever you say, or the minimum point, your dy by dx is equals to 0. Dy by dx is equals to 0. So first differentiate this. Derivative of your y 2x minus 8x to the power half equals 0. So this derivative would be 2 minus nx n minus 1. 8 will be outside, nx n minus 1. 1 by 2 minus 1 would be minus 1 over 2. Equals 0. So this will give you 2 minus 4x to the power minus half equals 0, and this will give you 4 over x to the power half will be equals to 2, and then x to the power half will be equals to 4 over 2 will be 2, and then x, if you square both sides, will be equals to 4. Okay, so this is your x coordinate for your stationary point, that is A. That is the minimum point. For by substituting this x value in your y equation of curve, you will get y coordinates. So y is equals to 2x minus 8x to the power half. So it will be 2 times 4 minus 8, 4 to the power half. So it will give you 8 minus 8 times 2 will be minus 8 minus 16 would be minus 8. So this will be your point A, 4 comma minus 8. Now these are the coordinates of minimum point A. Now, secondly, they are telling you about the point B that intersects the x-axis at B. That means here y will be 0. Okay, so on this curve, at some point, if y is 0, then if you substitute y0 in this equation, you will get your x value for it. So, taking it, putting y equals to 0 here, it will give you 2x equals 8x half. Okay, 2 right here for point B. Put y equals 0 in equation of curve. So x will be x to the power half will be equals to 4, and squaring both sides will give you x equals to 16. So this will give you point P to be 16 comma 0. So coordinates of point P. These are coordinates of point P. Okay, this is all about part A. Question 6. Okay, we get the coordinates of A and B. Now, part B. They say the diagram shows the curve with equation y is equals to 2x minus 8x to the power 1 over 2. Okay, so what is this actually? This is the same curve that we have used in the first part. Okay, this is the actual curve. We made an assumed curve by ourselves. This is the actual curve of this y is equals to 2x minus 8x to the power 1 over 2. And there is a line AB, and it is given that the equation of the line is this. So equation of line is this line. Okay, find the area of the shaded region between the curve and the line. Okay, so whenever we need to find the area of the shaded region between two curves, so the two things that we need is we need the coordinates of the points of intersection. So that is what we know for now. This is point A and this is point B. So what are the coordinates of it? We know A coordinates, we just have found in previous part that A coordinates are 4 comma minus 8 and B is 16 comma 0. Okay, so this means that this is your 4 value, and let's write it down here, the coordinates, so that we can write the x's value on of A and B, so 4 and 16. Okay, so these why do we find it? Because we need these as the limits to integrate our two curves. So how do we find the area? Area is equals to lower limit A to B upper limit, upper curve minus lower curve. Okay, one way of writing this is this, that upper curve minus lower curve, but this doesn't applies at all times. As far as this question is concerned, this doesn't apply here, because in this case the upper curve becomes this line and the lower curve becomes this line, but it should not be the case. Okay, there is one more way to understand this, and that is far minus near. Far curve minus, so what does it mean to be far and near? Far means far from the x-axis, so the farthest from the x-axis is this curve, so we can take this, and near to the x-axis is this curve, so we can take this. Or there is one more way to decide this, is that take any x value during this interval, okay, and substitute it in the y value. So the y value that is bigger one, either it is positive or negative. If it is a bigger value, then that would be your first function, and the smaller y value will be your second function, which you are going to subtract from the first one. Okay, but the best thing I think so that would be applicable at all times would be far minus near. So what is the farther curve? It is 2x minus 8x to the power half, farther from x-axis. So this is far, and this one is nearer to the x-axis. Okay, so 2x minus 8x to the power half is one curve equation, and nearer one is AB line, and its equation is 2x minus 32 over 3 and integration from a to b. So what is a? 4 to 16 are the limits. Okay, now just integrate it. So the first integration would be 2. I'm integrating each term individually. Obviously each term will be done individually, but we can do integration of this far separately and near separately by applying the limits and then just subtract them, or you can do it directly. Directly is far more better. So 2x square over 2 minus 8 x to the power 3 over 2 over 3 over 2 okay, then minus 2 over 3 x square over 2 and lastly plus minus minus plus plus 32 over 3x. So we need to apply now the limits 4 to 16 like this. Now just simplify it further. 2 and 2 cancel out, we get x square, then 16 over 3 minus 16 over 3 x to the power 3 over 2 minus 1 over 3x square plus 32 over 3x. Now apply the limits. First apply the upper limit minus apply the lower limit. Show them the whole working of applying the limits and just copying this just to substitute in the values. So in place of x, so 16 square minus 16 over 3, 16 to the power 3 over 2 minus 1 over 3, 16 square plus 32 over 3 times 16. Then 4 square minus 16 over 3, 4 to the power 3 over 2 minus 1 over 3, 4 square plus 32 over 3 times 4. Now just do directly. So this will give you 0 minus 32 over 3. So we get the area to be positive 32 over 3. So this is your final answer for your area between the region. Okay, so this is like the simplest way of doing it. Just applying the integration directly, deciding for your far and near correctly, and then just integrate it, apply the limits, and then do it directly with the calculator, and you will get your final value. Okay, so this is your whole working for your question 6, part B, and this is your part A. So this is your whole question number 6.